Baozi Training, excuse me, Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. We're here to help you land your next dream offer. And also, feel free to check out our technical blog right here. And for those viewers in China, because I also publish those videos in Bilibili, so you can also see all the articles here as well. So this is where Tencent Cloud is indexing our WeChat group, where we constantly publishing all those articles. So they did a nice index, and then things working fine. And I think also we have a CN blogs. So here, if you can go to CN blogs, how do I search actually here? You know what? Let me just do CN blogs Baozi Training. It's not really indexed very well. Oh, maybe just try this then. It's not even showing up in the first page. So yeah, it's understandable because I just started this not a long time ago. So we also have this. So for the viewers in China, you can, this is not blocked because Blogger is blocked in China. So you can also check out the Leetcode solution here as well. And yes, for viewers in China, I think you probably already noticed there's a channel on Bilibili where I also double publish these videos here. And for the viewers in the States, so what is Bilibili? Bilibili is actually pretty cool. It's like a video sharing. It's like a YouTube basically in China for Generation Z. So by Generation Z, what I mean is there used to be this thing called Youku, which is supposed to be equivalent of YouTube in China, but it's totally trash. It's so hard to use. And the Bilibili technically is very good. And then content mostly is about, used to be just about cartoons, mangas, but now it's literally about everything. And it's for younger generation of the Gen Z people. So not really for millennium. Like millenniums can still upload videos, but those Gen Z kids are really, really smart and they are expert. Actually, in order to publish some videos in that, you have to take like a 2 hours test. So I tried my best to take the test and I passed. That's why I can publish those videos. Anyways, okay, just check that out. So today we're going to talk about this problem called edit distance. So I think I mentioned in the word distance problem about edit distance, which is two completely different problems. So edit distance is a classical problem. So giving you two words, word A, word one, word two, and you have three operations: insert, delete, and replace. And then they want you to find the minimal number of operations required to convert word A to word B, word one to word two. So this is example horse. How do you do this? So you replace H and then you remove and you remove and then you get this. Another example. The thought process whenever you look at this problem, right? So the brute force way is definitely doable, but it's just definitely overkill because we will essentially, they only want you to find the minimal and it's the numbers. You don't need to give the sequence as well. And you will be totally overkill exponential time complexity if you're doing that, because the way you're going to do that is, okay, you're trying to basically try every different combos. The recursion termination is, I should add it. So if the two words equal to each other, then you can just return the minimal steps. If not, you can return a minimal minus one. And then for each of the iteration, you try three different ways, right? You either insert, remove, or replace. So essentially you try different things. And then you cut that character, not character, and then you continue the recursion. And then you compare the minimum of that three method, which one is minimal, and then you just keep doing this. So once you realize it's definitely not optimal, once you realize it is a very classical problem, you just kind of remember this. For example, we used to do this coin change problem, right? So giving you a number and then giving you like you have a quarter, you have a nickel, you have a penny. What is the minimum number of coins you need to do? You just, okay, no, this is actually a DP problem. So the mathematical induction function is also kind of like really typical. So it's let's say if you have two-dimensional arrays, dpij represents the minimum operation needed to convert, at that moment, a string from char from 0 to I to string char from 0 to j. So the initial value you're going to initiate, I will it's not all zeros because I will show you later. So it's actually equals to the string length. So if the two characters are equal, you can just directly get the diagonal values out because those are equal, right? So you just inherited the best minimal solution from the previous iterations. Else, you can try three different things. So this is essentially the three different operations, right? So you try either insert it, remove it, or replace it. Essentially, it's like the top neighbor, left neighbor, and then the diagonal neighbor on the left. And then you plus one is that operation. So if we run one example super quick, it will look like this, right? Let's say this is a horse and then this is ROS. So see, previously it's 3 times 5, but normally when we do DP, we want it to plus 1, right? So it's 4 times 6. So you can see this array, 4 rows, 6 columns. And then for the 0 part, right? So you want to give the initial value. So if you have an empty string, you want to change it to H, how many do you need? 1. If you want to change it to HO, what do you need to do? 2, because you need to insert H and O. So far and so forth. So this is basically the initial value. And then same thing here. So 0 changes to R, 1. If you need to change it to R, you have to insert it twice for an empty string. So 1, 2, 3. So now let's calculate this, right? So for H and R, what is the minimal value? Like I said, if they are not equal, so that will need to be the minimal value of this, and this plus 1. So what is the minimum value of this? So it's 0, so it's 1. So if you see, it will basically, that will be a replace operation from there. And then you just continue this. So when you are here, what is the minimum value? So R and O, they are not equal. So that is basically the minimum of all of those. So basically that is 2. So that means what we can do is we can choose to remove H, or we can choose to, two steps. We can choose to R and H, 2 steps. So we can choose to remove H and then we replace R. Sorry, we remove H and then we replace R with O. That would be it. And so same thing here. So but if R equals to R, so what is the minimum? So you inherit it from essentially here. So you get a minimum value of 2 because you don't need to do anything. And then that's essentially the previous values. And then so on and so forth. They are not equal, so this basically equals to 3 because 2 plus 1. And then what is this value? They are not equal, so that equals to minimum 3 plus 1, which equals to 4. So doing the same thing here, right? So it will be 2, they are equal, so carried over is 1 because this is the value. Not equal, this will be 2, 1 plus 1. 1 plus 1 equals 2, as they are not equal, so this could be either way. 3, they are not equal, so this would be 4, this either way. As they are not equal, so 3, and then this, they are not equal, so 2. So R and S, so why there are 2, right? So if you see HO and ROS, so you can just kind of trace it back. So you can leave the O is the same, you remove this, and then you replace H or R. R and S, they are not the same, so this will be 2. S and S, they are the same, carried over, it will be 2. And E and S, they will be not the same, so basically it will be 3. So the best answer is 3. So regarding the coding part, once you have this formula, the coding part should be straightforward. It's literally just converting this formula to code like this. Time complexity, space complexity, both O times of n, and that's it. So actually, if you understand the dynamic programming, this kind of a classical problem is straightforward, so easy to implement. But this will be very unlikely in interviews, but you just have to know it. Okay, this is a DP problem. This is how you code up a DP problem. This is a template. Initial values, formula, return the value. And then normally you will allocate the array one size larger. Okay, that will be all. Until next time, see you guys next time. If you like the video, hit the like button and then subscribe to our channel. Thank you very much. Bye.